Hi guys, I am S. Gayatri from BSc Data Science. Show that the function f given by f of x is equals to x cube plus 3 if x not equals to 0, 1 if x is equals to 0 is not continuous at x is equals to 0. It should be we have to show f of x is continuous at x is equals to 0 if LHL is equals to RHL is equals to f of 0 if limit 0 minus x tends to 0 minus f of x is equals to limit x tends to 0 plus f of x is equals to f of 0. Finding LHL and RHL. Here LHL at x tends to 0, RHL at x tends to 0. The two possibilities should come. So left continuity and right continuity we have to find out. Then limit x tends to 0 minus f of x is equals to limit h tends to 0. F of 0 minus h we need to take. X minus h we need to take. In the x place we have to keep 0. Limit h tends to 0 f of minus h limit h tends to 0 minus h cube plus 3. In this function we have to substitute minus h and 0 in the h place we have to substitute 0. Then it would get 0 cube plus 3. What the output is 3. Then left and right hand side limit x tends to 0 plus f of x is equals to limit h tends to 0 f of 0 plus h. In this first we have to take x plus h because it is right hand side. So is equals to limit h tends to 0 f of h is equals to limit f of h is equals to limit h tends to 0 h cube plus 3. In this h place we have to substitute 0 cube plus 3. Again output is 3, but f of 0 is equals to 1. So LHL is equals to RHL is not is equals to f of 0. Hence f is not continuous at x is equals to 0. Then let us go for the next example. Is the function f defined by f of x is equals to x if x less than or equal to 1, 5 if x greater than 1, continuous at x is equals to 0, at x is equals to 1, at x is equals to 2. Here three functions are there: x is equals to 0, x is equals to 1, x is equals to 2. We need to find out them. Give f of x is equals to x if x less than or equal to 1, 5 if x greater than 1. At x is equals to 0, f for x is equals to 0, f of x is equals to x. Since this is a polynomial, it is continuous. Since therefore f of x is continuous for x is equals to 0. So next, at point x is equals to 1, f of x is continuous at x is equals to 1. Since there are two different functions on the left and the right of 1, we take LHL and RHL. So if LHL is equals to RHL is equals to f of 1, if limit x tends to 1 minus f of x is equals to limit x tends to 1 plus f of x is equals to f of 1. F of x is equals to x if x less than or equal to 1, 5 if x greater than 1, LHL at x tends to 1, RHL at x tends to 1. We need to find out both left and right continuities. Limit x tends to 1 minus f of x is equals to limit h tends to 0, f of 1 minus h. Limit h tends to 0, 1 minus h is equals to 1 minus 0. In the place of h we need to substitute 0, so that equal to 1 we get. Limit x tends to 1 plus f of x is equals to limit h tends to 0, f of 1 plus h is equals to limit h tends to 0, 5. In the place of h we need to find out in the place of h we need to substitute the value 0. Then we get f of 1. The value of f of 1 is 5. The output is left hand side 1 and right hand side 5. So that since LHL is not equal to RHL, f of x is not continuous at x is equals to 1. At x is equals to 2, for x is equals to 2, f of x is equals to 5. Since this constant function, it is also continuous. Therefore, f of x is continuous for x is equals to. And also, thank you for giving this opportunity.